Okay, these examples are from the extra practice that I emailed you. We're asked to find the interval of convergence and I believe the radius of convergence. Let's start by finding the center. This one is written a little bit differently. Usually we have some coefficient and then x minus some number to a power. So a is the center because a is the value that makes this whole power series 0. In this case, we have this little coefficient out front, so it's not the same. So again, we still want to think about the center is the value that makes the power series 0. So if this thing were 0, then obviously 0 to the n over n, all of that would go to 0. So if 3x minus 2 is 0, everything is 0. So what value of x makes this 0? Well, add 2 to both sides. And of course, x is going to be 2/3. So our center is at 2/3. Okay, now let's go ahead and apply the ratio test to try to find the interval of convergence. Oops, sorry, ratio test. So we have the limit as n goes to infinity of, and I am going to put absolute values here. I was careless with this in the last video and maybe even sometimes in class. The absolute values are needed because x could be positive or negative, right? Even though it's not an alternating series per se, we don't know the value of x. Maybe this whole base will be negative and make the whole thing alternating. So it depends on x. So let's keep the absolute values there. So we have the nth plus first term divided by the nth term. I'm going to write that because some of you were not doing that carefully on your quizzes. So the ratio test is to take the nth plus first term over the nth term. So I'm going to flip and multiply by the original. And so this we could write as 3x minus 2 to the n times 3x2 to the first. So the 3x minus 2 to the n part is going to cancel, and we're just going to be left with 3x minus 2 to the first and an n in the numerator and just an n plus 1 in the denominator. Now as n grows large, the numerator is a first degree polynomial for n, and the denominator is a first degree polynomial in terms of n. And so this limit is going to go to the absolute value of 3x minus 2, right? Because it's the coefficient of the numerator. So the ratio test says this thing converges for values where this result is less than 1. So we're looking at values of 3x minus 2 between -1 and 1. So how do we solve for x here? We want to get x by itself. Think about algebra. We want to add that 2, but we're going to add 2 to all three sides. So we get -1 plus 2 is 1, less than 3x, which is less than 3, and then divide by 3. Because again, this is trying to get x by itself. So x is between 1/3 and 1. And notice that the center is 2/3. It really is halfway between. So if you want to visualize this, we have our center at 2/3, and then 1/3 and 3/3, or 1. So our radius of convergence is the distance between the center and the endpoint of either endpoint of the interval of convergence. So the distance here is 1/3, and whether you think about it here or here, the radius is 1/3. So the radius of convergence is 1/3. The interval of convergence we're not done with. This is why this is a harder question. So we have to check the places where where the ratio test is equal to 1. So we know it converges for values when this is less than 1, but if the absolute value of 3x minus 2 is equal to 1, we've got an inconclusive result. So that's going to happen when x is 1/3 and x is 1. So let's check those endpoints separately. If we let x equal 1/3, our series becomes 1/3 times 1/3 times 3, right? We're putting 1/3 in for x. 1/3 times 3 is 1, minus 2 is -1 to the n over n. So that's our alternating harmonic series. We've seen this lots of times. So it's alternating with a sub n being 1 over n. So we know that 1 over n is going to be greater than 1 over n plus 1. So that's satisfied. And we know that as n goes to infinity, 1 over n goes to 0. So we know that this series converges. It actually converges conditionally because this is the harmonic, but we don't really care about that. It converges. And so that was when x equals 1/3. So that converges. It's going to be in our interval of convergence. Now let's check what happens when x equals 1. Our series becomes 3 times 1, or 3 minus 2 is 1 to the n over n. And this is, the numerator is just 1. So notice this is our p-series. This is our divergent p-series, divergent harmonic series. So the difference between the alternating harmonic converges, but the regular harmonic diverges. So we are not including it in the interval of convergence, and so there's our interval of convergence. Okay, let's check. Let's do the next one. We've got 2x to the n. So the center here is going to be 0, and let's apply our ratio test. Okay, so this is going to be 2x to the n times 2x to the first all over 2x to the n. So those are going to cancel, and we're left with the absolute value of 2x. Ratio test says this converges for values less than 1. So that's where 2x is between -1 and 1. Solving for x, that tells us that we're looking at values between -1/2 and 1/2. Now our center is at 0, so we can see that visually that the distance between 0 and one of the endpoints, in other words, our radius of convergence is 1/2. And our interval of convergence, we're not done. We have to check these endpoints. So if we let x equal -1/2, then our original series, so again, we're replacing x with -1/2, so we're going to get -1 to the n, which is, of course, a alternating series. You know, this is 1 plus -1 plus 1 plus -1. So this diverges by nth term test. And then, so we're not including that in the endpoint. And then if we check x equals +1/2, our series becomes 2 times 1/2 is 1. So 1 to the n, which is just 1 plus 1 plus 1. This also diverges by nth term test. So our interval of convergence does not include the endpoints. It was just from -1/2 to 1/2. Okay, let's do the next one. What's our center? The center is the value that makes this whole series 0, which would happen if 2x plus 3 is equal to 0. So that's going to happen at -3/2. So that's our center. Okay, so ratio test, we're going to apply the limit as n goes to infinity of 2x plus 3 to the, when I replace n with n plus 1 in here, think about what happens. The 2 times n plus 1 plus 1, we're going to get 2n plus 3. And then we flip and multiply by the original. Okay, so now we rewrite it so we can simplify this a little bit. So we're going to get 2x plus 3 to the 2n, 2x plus 3 cubed, n factorial. And the denominator, we have n plus 1 times n factorial, and 2x plus 3 to the 2n, 2x plus 3 to the first. Okay, so 2x plus 3 to the 2n's, those cancel. One of these cancels, so that would be squared, and the n factorials cancel. So we have the limit as n goes to infinity. We're left with just 2x plus 3 squared over n plus 1. I think that's it. And so now as n grows large, this whole thing goes to 0 because the numerator has no n's in it. So degree of the denominator is larger. Now that's always less than 1. So that tells us that converges for all real values of x. Our interval of convergence would be from -infinity to infinity, and our radius of convergence would also be infinite. Now, it might seem a little bit weird that the center is -3/2, and that doesn't seem halfway between -infinity and infinity. But of course, -infinity and infinity go on forever, right? So -3/2 certainly is in the center of that. Okay, let's look at the next one. So the center here is 4. And let's apply the ratio test. So we have n plus 1 factorial. And then we have x to the 4 to the n plus 1. So I'm just going to write this all simplified, or all sort of factored out, ready for some canceling. And we're just left with the limit as n goes to infinity of n plus 1 times x minus 4. As n grows large, this thing will go to infinity, again, assuming this thing is not 0. So as long as x is not equal to 4, we get infinity. Now that is greater than 1, so the ratio test tells us it diverges. So it diverges for all values of x except at x equals 4, right? Because at x equals 4, the center, remember, was at x equals 4. So we know that the whole power series is just the 0 series when x is equal to 4. So the interval of convergence is just a single value x equals 4. It's just one number. So the radius of convergence is 0. There's 0 distance between the center and the endpoint of the interval of convergence. Okay, we just have one more example left. So the center of this one is whatever makes 4x minus 5 equal to 0. So that's where 4x is equal to 5, or x equals 5/4. Now let's apply our ratio test. So we're going to get, again, careful when we're replacing n with n plus 1. So we're going to get 4x minus 5 to the 2n plus 3 power. Right, and then we have n plus 1 to the 3/2. We're going to flip and multiply by the original. And again, I'm going to write 4x minus 5 to the 2n plus 1 as 4x minus 5 to the 2n and 4x minus 5 to the first. So I'm just doing that to help me cancel stuff. I can cancel one of these with that. Okay, so what's left after all of that? We have 4x minus 5 squared times n to the 3/2 all over n plus 1 to the 3/2. Now, these aren't polynomials, but the degree of the numerator still is to the 3/2 power, and the denominator is still behaving as something to the 3/2 power. So these are both the same degree, and so the limit as n goes to infinity is just going to the coefficient, sorry, leading coefficient of the numerator over the leading coefficient of the denominator. So we get just 4x minus 5 squared. Now, we can drop the absolute values because it's the same values that make 4x minus 5 squared is always going to be positive, right? This is always positive. So we don't really need the absolute values, but we're looking to see where are the values that make this less than 1, right? So we know that the values that will make this thing be less than 1 are still the values that where 4x minus 5 itself is between -1 and 1, right? So let me make sure this is clear to you. If we have a value and we square it, and the value is between -1 and 1, when we square it, it stays stays less than 1, right? It stays between -1 and 1. So we're looking at where, so I think actually they explain this pretty well down below. So let me just go to their answer key, right? So the point is, we get 4x minus 5 squared. We're looking for where is that less than 1. That's just where the actual value of 4x minus 5 is less than 1. Right? So if you think about like your polynomial, 4x minus 5 squared, where is it less than 1? It's between values of -1 and 1. Right? So it's the same thing as looking at where this thing squared is less than 1 is the same as looking where the absolute value is less than 1. So we're looking at values of 4x minus 5 between -1 and 1. Okay, so let's get back up to that. How do we solve that equation? Well, we add 5 to all 3 sides. So we get 4 is less than 4x is less than 6. And then dividing by 4, we get 1 is less than x is less than 6/4, which is 3/2. Okay, so is 5/4 really in the middle? And you have to be careful here, right? So we are looking at between 1 and 1.5. What's halfway between 1 and 1.5 is 1 1/4. So our center really is in the center. And our radius of convergence is the distance between the center and one of the endpoints. So that's 1/4. Okay, so our radius of convergence is 1/4. Our interval of convergence, we're not done because we have to check, check these endpoints. And I just screwed up my, how do I move that down now? There we go. Okay, sorry about that. That still didn't even work. There we go. Okay, now I got myself some room. Okay, so we have to check our endpoints and crazy stuff happening. Okay, back over here, I lost my 1 less than x less than 3/2. Okay, so I need to check the endpoints at 1 and at 3/2. When we let x equal 1, my series becomes 4 minus 5, which is -1 to the 2n plus 1 power over n to the 3/2. That exponent is always odd, so that's the same thing as just -1 over n to the 3/2. We can factor that -1 out, so it's just the -1 times the p series 1 over n to the 3/2. Since the p series converges, -1 times the p-series converges, so we include x equals 1 in our interval of convergence. If we let x equal 3/2, then our power series becomes, so 3/2 times 2 is 6, minus 5 is 1 to the 2n plus 1 over n to the 3/2. Now this is always odd, but it doesn't matter because it's 1 to an odd power. So that's the same thing as just 1 over n to the 3/2. So again, that's our convergent p-series. So we include 3/2 as well. So our interval of convergence is from 1 to 3/2. So hopefully these extra problems helped you guys out.